Hello and welcome to today's Tech Talk about what to know about practicing operations research and decision science in industry. My name is Haley. I'm part of the Nextmv team who will be supporting today's event. Our presenters today are Ryan O'Neill and Thiago Serra, and I will let them formally introduce themselves here in a moment. But just a few housekeeping items as we dive into the conversation today. You are more than welcome to ask questions of Ryan and Thiago throughout the conversation. They have a couple of topics that they'll cover. But feel free to drop your questions or comments into the chat off to the side. Just keep an eye on that hosts and panelists versus everyone toggle to make sure that your question or comment goes to the right place. Additionally, you can use the Q&A feature at the bottom of your screen. Myself and a couple of other folks on the Nextmv team will be monitoring that and making sure that those questions get surfaced to Ryan and Thiago during the dedicated Q&A time at the end. But again, feel free to ask questions throughout. Today's session is being recorded, and we'll make sure to share it with folks afterwards. If we don't get to a question before the time is up today, we'll make sure to follow up with you over email. So with that, I'm going to step back into the Zoom backstage and let Ryan and Thiago take it away.
Thanks, Haley, and thank you for everyone for joining us today, and thank you, Thiago, for having this conversation with me. So as Haley mentioned, I'm Ryan. I'm the co-founder and CTO here at Nextmv, which is a decision ops platform for optimization models. My background is in obviously operations research, but before that I was a software engineer for a bunch of years. So I came into this field from a software background. I did my PhD at George Mason University under Carla Hoffman and worked on on-demand routing problems for a number of years before starting this company with my co-founder Carolyn. And I live in Maine, so that's me in a nutshell. Thiago, why don't you take a stab at an intro too?
Hello, folks. My name is Thiago Serra. I'm currently an assistant professor in business analytics at the University of Iowa. Now, my career started similarly in software engineering. At some point, I decided that I like optimization more than I liked writing software in general. So I started swaying this way, working for a consulting company, then working at Petrobras. It's a major Brazilian oil company. Then I came to the US. I did my PhD at Carnegie Mellon. While doing my PhD, I worked for Mitsubishi Electric in summer internships. I was since then a visiting researcher there. I'm currently serving there like as a consultant. And finishing that stage as a visiting researcher at Mitsubishi, I moved as a professor to Bucknell. Spent 5 years in a place that had a balance between teaching and scholarship. And now moving to Iowa, it's a little different. There's a greater focus on research, but also I keep teaching. And a lot of what I teach or what I do as research has something to do with optimization. But of course, these days, it's hard not to combine that with machine learning, for example. So this is what I've been doing for the last 7 years.
Yeah, sorry. That's the comment about combining it with machine learning. I feel like that's very much in the spirit of where we want to go today, right? Yeah.
We should get down there at some point, I guess, or at least we're hoping for to.
Right. So Thiago, I think it's been not that long since we were both in training. I think one of the funny things about optimization is we're in a way when we teach it, we're a little obsessed with our origin story, by which I mean, I've written this blog post, I'm guilty of this, is we frequently start off with like 18 years ago, our founding father, George B. Dantzig, invented linear programming to solve complex decision problems that are resource constrained. Let's talk about how we teach optimization, right? What are the ways that people come into it? What observations do you have about how we train people to do this? And what are the current trends and what does the future look like to you?
Well, I find it tricky to talk about training people in optimization because I feel that optimization often pops up as an elective, advanced course. And depending on what your major is, that course is going to have very different taste. Back at Bucknell, there were 2 people teaching optimization. There was me and Lucas Waddell. His class would have theorems, whiteboard, like a blackboard, proofs, and so on. And mine
Yeah.
would be entirely on modeling aspects because he was in math, I was in the College of Management slash business school. You have people coming through engineering that are going to have a more hands-on focus. You have people coming through computer science that are going to look more into algorithmic aspects. But the feeling that I have is maybe we're not really training optimizers. We are leaving some breadcrumbs and they build themselves. You know?
Right. That's interesting. Yeah. I also had a very sort of formulation heavy training under Dr. Hoffman at George Mason. And I thought that was one of the most fun aspects of the field and really what sort of kept me interested in it above anything else was like, how do I take a physical process in the world and then convert it into something that is efficient for a solver to optimize? Um, yeah. Um, I'm curious.
But, I have this theory. Think about folks that come through CS or that don't come through CS, right? Um, I mean, I had many students that felt cheated by me because I brought them to do research machine learning. And suddenly they were formulating optimization problems.
Right.
And then they realized that they learned these algorithms. This is an NP hard problem. You don't go there. And they feel, well, I mean, why are you making me do this? And I think like sometimes when your first step is through optimization, maybe, through computer science, you don't feel that this is a place you should go
Right.
because it's hard. But I mean, if one thing we learned with neural networks, for example, is it doesn't matter that we can't really find the global optimal solution. I mean, as long as you can find a good enough solution or you can scale to the size of the problems, right? It works. But
Yeah.
bringing people from computer science is a little difficult sometimes because they have been taught this is NP hard. Don't go there. Or
Right.
proceed with caution, right?
Right. And there's sort of an interesting sort of historical aspect there too, which is like a lot of the complexity theory development came out of sort of early failures in research from like the 60s, where we didn't understand complexity theory, but so much has changed, right? I think it was my first Informs where I went to a talk where a professor put up a slide or said something like, NP hard is a term we use to scare graduate students. Right. But so much of what we actually do in optimization is just, well, we have to solve it anyway. So let's just figure out what we can do. You reminded me that there was a specific for me there was a specific moment when I actually became aware of optimization as a field or operations research as a field. And it was reading David Goldberg's book on genetic algorithms. And he kept talking about NP hard problems and this field where they would just solve them anyway. And when I read about that, it was like, that's what I want to do. I wonder if there was a specific moment for you like that, or can you remember one?
Well, honestly, I chose computer engineering as a major because I want to make sure I would make a living out of it, or my family wanted. So like it was like a combination of factors. But I wasn't excited about the prospect of computer programming in general, or like being a computer engineer in general. But the first time I remember that I had one professor in my first semester. I went to his website and I saw he worked with this thing called combinatorial optimization. I was like, huh, so
What's
you
that?
can write code to do non-trivial things, interesting things, automate decision making, like make more with the same amount of resources. And that really that took off in some
Yeah.
way.
Yeah.
And I feel like there's a lot of different experiences you can have that could like developmental experiences that can take you in this path, right? And not every two people are going to have the same ones.
So you've got a bunch of people coming from different backgrounds into this field, right? And it's a little bit of a mixing or melting pot. We've got people coming from stats and math and computer science and industrial engineering and so on and so forth. Um, what what makes people successful as they actually start to apply it, after their training?
Well, I mean, they should bridge these gaps that we have in education. So if you have someone coming from, let's say, a computer science background, I mean, this is a personal perspective. I could be wrong here, but I would imagine someone more hands-on who is going to just find a way to solve the problem at hand and maybe not take that step back of framing the problem, formulating the problem. And sometimes you're going to formulate problems, but let's say if you you could potentially formulate a problem and give it to a solver. And maybe you're lucky enough that it gets solved. But even if you know your problem is too hard to do that, framing that problem first is very important. So that I think having this exposure for different lenses of what optimization is very important. So if someone comes from a modeling perspective but haven't spent a lot of time coding, that coding aspect is also very, very important. And I mean, in my undergrad years, I think the most relevant experience for me was actually computer programming competitions, because that really made me think about implementing algorithms and about the fact that machines
Yeah.
have limited resources. I know people forget that these days. High level programming languages let the LLM solve the problem for you. But there's, if you really understand how to use your machine well, there's so much more you can make. And the optimization, that's
Right.
very important. I mean, I think it's a sign of that when you see, for example, like Ruby having that thing called Ruby Academy, where they're looking for people to train themselves, because there are certain skills that we don't expect to see in the college degree anymore. For example, low level programming, like learning how to code in C, C++. These things are going away, but if you don't have those, there are certain tasks that you cannot perform well.
Mhm. Yeah, one of my favorite classes as an undergrad was assembly language. And I
Oh,
remember going
that's
into like turbo assembler, right? And you had this sort of view, this like, I don't know, curses style view, right, of the machine, and you could go watch things going into registers, and it was a lot of fun. It was very slow programming though, right? It was nothing like what people do now. Um,
but you know that's let's say I just propose that we flip something we planned earlier
sure.
and plug generative AI here, large language models, right? Because I think that's very convenient with what you mentioned. Because we learned, I did my assembly, you did your assembly. Okay, that was only one semester for me and some more theory later. But what was well established back when I was in college 20 years ago was, well, we can do assembly, but if you write code in C, compilers have been optimized so much, it doesn't matter. It's going to be as efficient as, right? So
Sure.
we usually don't ask people to write assembly anymore. If you know C, you're good. Um, well, that's not something as Python. It's not that efficient. But when you think about the large language models, it's somewhat a similar discussion about skills. You can quickly ask a large language model to formulate an optimization problem for you. And that formulation can be quite okay. And let's say the same way that scripting can be very good at solving certain problems. But one rule that I keep seeing for an optimization professional is to make sure that you have a model that's actually good enough to scale in practice, right? And I think it has a lot to do with, like, I mean, my perspective coming from like computer science makes me think about that. I mean, does this solve the problem? Maybe. Does it solve well enough? Maybe not. Because you could potentially have a valid model, but it's only with like all this studying about from strong formulations about like convexification that you may start understanding, well, this is an okay model. I could write a much better model. I could like write a callback function that could make solving this much better. So at some point, maybe we're not going to have optimization professionals solving simple problems, right? But
Right.
we could never afford that. I mean, like a mom and pop shop cannot pay for like an optimization professional, but now they could ask an LLM to maybe produce an optimization model that could do that for them, right? But bigger companies are going to afford that extra inch.
Yeah. Well, yeah, and honestly, like nobody goes out into the industry, right, and like solves a set cover problem, right? Unless it's
Mhm.
something else that you've reformulated as a set cover, right?
Mhm.
I one of my a model that I worked inherited that did routing, for example. I mean, it had like at least a dozen different things that could be put into the objective function, right, in a routing model. And so it's things like how do you balance driver pay, or late time versus early time versus tips versus blah 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 blah. Um, and so like none of these, once you're in the real world, like the models become so sort of impure, right? That you really have to it, it gets into the understanding what the stakeholder requirements and being sort of a subject matter expert in that field are in that domain. And so, for example, I've been using some LLMs to do some coding assistance for testing out NVIDIA's co-op routing library. So we've added it to our platform, or we're adding it to our platform. And it can be an accelerant in writing the model, right? But what it gives you back isn't necessarily even real. Like the first thing it might give you back is a model where the drivers are going back and forth 50 times. And yes, it solves the problem, but you have to like look at the output and understand how a subject matter expert in doing on the ground logistics would actually look at that and say like, no, that's not right. And so in a way, it's like, yes, it is helping you with some of the modeling and the coding, but now you have to step up a level, right? And think more from the business side of it.
Yeah, I find it very interesting. I mean, there's one consulting company that I admire a lot in the area, which is Princeton Consultants. Their CEO is a philosopher. And when he like Steve Sachihara has a book about the optimization edge, and when he gave a talk, I invited him to CMU when I was PhD student. He emphasized a lot the human aspect of things. I mean, if people don't buy in, it doesn't matter what you're doing, and that applies to optimization, applies to machine learning, applies to many other places. I think with optimization, it hits a little more strongly because first you're questioning the decision-making ability of the people who should be collaborating with you. So you're basically replacing them. There's this feeling you're replacing them. I mean, I actually are trying to make them more productive, and in many ways you are. But I mean, it does come with some questioning, right? And also, and one interesting example I had from from our early days working on a consulting company, we had this logistics software that would figure routing for trucks, but we would also figure out how to put the cargo inside the trucks. So I mean, if you're visiting one place first, the back of the truck is going to have the items should be delivered there, and you would like build the container loading that way. But also there are physical constraints. I mean, you cannot stack like 3 ovens or 2 fridges because it's too heavy, it's frail. But the system, going back to your point earlier, the system had regional configurations because to put in simpler terms, one of the companies that was a client, they had factories all over the country, and people in certain parts of the country, they were very they were very like they have that empowering feeling. I know what I'm doing. It's not this engineer from like the south. In Brazil, like there's this south-north right contrast sometimes. It's not these folks from the south that are going to tell me what I can and cannot pile inside this truck. I'm going to put more, and I don't care. So either you accept that regionally the configuration is going to be different with some risks, or the system's not used.
Yep.
I do wonder, like you do have like a way more broader experience in software engineering. Last time I worked as a software engineer, we were coding in Java. You have been there,
People still use Java.
but that was the main thing. I imagine you would have more stories like that to share.
Um, one of the things what you were just talking about made me think of was when we were working with a company that was doing, delivery, and we were, showing them all these routes where, you know how like a capacitated vehicle routing problem, the typical routes that you get out look like pedals, right? So you start at the depot and you sort of go in a loop and you come back, right? And that's usually what the optimal solution actually looks like. And we'd show them these solutions and we'd improve on the objective value. And it took a while to realize what they actually wanted was something where it was essentially clustering. And this is very, very common. If you think about, like you're an Amazon delivery driver, what you want to do is you want to get on the highway, go to a neighborhood and do all the deliveries, right? So you like drive for like 20 minutes on the highway, don't make any stops, get somewhere, go around all the suburbs or the cul-de-sacs or whatever, do all the deliveries and go back. And it's like there's this big disconnect between what the operators need and want and understand about on the ground operations and what the actual optimization will do if you just sort of code it to do, let's minimize the total time, right? It's a very different thing. But yeah, you mentioned, oh, hi Hale.
I'm back because there's a couple questions that are popping in, so I'm interrupting here. And I think one that has come up that I think is relevant to the thread that you were probably just about to pull there, Ryan, is a question that came in through the chat here around for students like us who are studying business analytics, what would you recommend we focus on to build strong practical skills in operations research and optimization for industry roles? That could be for either one of you.
Doug, I'll let you take that one first.
Okay. So what I can say, well, I teach business analytics students in a business school, but I'm always thinking about what are the skills that we can't cover in class because there's only so much we can add on top of the business curriculum and not deviate too much. The first thing I tell students to do when I'm advising them, if they have the time, is if they're done with first computer programming course in Python, doesn't matter if it was in a business school or somewhere else, that they try to go into like a data structures class because it's not enough coding proficiency. Like more exposure for a longer period of time, thinking about slightly larger pieces of code and how you would use different data structures is very important. If you can get to the point where you also like take a more advanced course in algorithms, that's amazing. I think there's a similar question from Nima Hijazi about branch of math. I mean,
Yeah.
just say like something that it sticks true throughout my life. It always starts in linear algebra, optimization, machine learning, data science. That linear algebra and statistics and probability in the beginning is very, very important. And from that point on, there's certainly other types of courses you can take. It varies a lot from about depending on where you are and what is available to you locally, right? I did dive into a bunch of books about optimization myself because, well, I like that and I didn't see the courses coming my way. There are certain books I could certainly recommend if you would like, if you say like which stage you are, what you want to see next. But let me stop talking.
I
Give
like
some room here.
The Thiago reading list would be awesome, actually.
Yeah, there's a blog post
And
for you.
exactly. There's another question that came in through the chat that maybe Brian, I'll have you take a stab at first around how can companies best structure their teams to ensure OR and DS insights are adopted and used effectively across different business units?
Yeah. This is obviously very organization dependent, right? So it depends on how your organization is working. But I can say what I've had success with in the past is highly integrated teams, where we have people who are doing data science or machine learning directly integrated and working on teams or squads or whatever you call them with the optimization people and the software engineers. And typically, what we'll do is front load a few more engineers on there. So it might be like a data scientist, one OR person, and like 3 engineers or something like that. This is probably changing in the world as these teams, we are seeing optimization get more adoption in technology organizations. So, I expect those ratios change. I think we were doing 5 engineers to one quantitative engineer at one point, but yeah, that worked well for us. And the upside there, one is the OR people and the data science people have this sort of direct path into the business, right? Like you can get things into production quickly, you can iterate on them. You're writing production code from day one. And so those are very positive things. The downsides there are one, you have to write production code from day one, right? And so like not all people are comfortable doing that because they don't necessarily have the background. That can be learned though. That's not that bad. And two, there's a lot more advocacy. And so you're going into an environment for people where people just don't really know what you do. And so you need to have some comfort advocating for the field that you're representing and the skills that you're bringing to the table and when to use them and when not to use them.
There may be a follow on there. I think this is related to what you were just sharing here, Ryan, of how do organizations balance the rigor of operations research models with the need for quick, actionable business decisions? I think, Thiago, you were touching on some of this as well. So I'll let either one of you start.
Yeah, let me see if I can start a fight here. So I would say that for the most part, organizations don't care about rigor. What they care about is something that they care about some sort of repeatable decision making in a production environment. that it needs to be understandable. It can be you can communicate about it and explain it to people. It needs to be repeatable. It needs to be consistent. Like it should always, make decisions at roughly the same amount of time. That kind of stuff. And that once we get into the rigor of things like optimality bounds, we've essentially lost people. Those are important to us, and they should be. But I've seen projects fail because we started talking about optimality bounds to the end user, and they become obsessed with closing the gap. And then now the project was not about what we were doing. It was about how do we close the gap. So let's talk about the math. And so that was the wrong place for us to be. But I'm very curious what Thiago's opinion is on this.
So I think I don't want to mention the company because I don't want to speak on behalf of the company, but one company I visited some years ago, they mentioned that it's difficult for them to work with someone who is mostly trained on modeling because this was like a very, very large scale company because at some point there's no model that's going to run in practice. At some point, this is going to become a hope for the best possible feasible solution you can get. So coding skills and coming up with something that works is going to matter more than finding the optimal solution. So there is some balance there. At some point, companies may afford the luxury of, well, I'm going to pay a person a good salary to close this gap. But that's going to be, let's say, a very large infrastructure company. Think energy, think an oil company, where, okay, if we could do 2% better,
Yeah.
that would be millions. These people are going to pay us a good salary for you, but other companies, they will want something that works well in practice, and that's it. So it's going to vary a little bit. The rigor is going to depend on how much they see value in that.
Yeah, we like Carolyn and I, when some of our last gigs, like things would be moving so fast that we would never get to the point where it's like, oh, 1% here meant anything, because like the ground truth had changed. There was so much like drift within the operating environment, right? That we were having to adjust models to keep up with that, as opposed to like things being in a static environment and sort of squeezing an extra 1% out a lot of the time.
So I think like many people get interested in optimization. I want to pick like a question by Shivanji Kapoor. Um, there is a certain jump, right? When we go from, let's say, statistics, probability, like a forecasting, any type of analysis like that to decision making, right? I think the most important aspect to think here is that we may have multiple decisions, typically decisions that are discrete. Am I going to do this or that? They have to be combined. They have to fulfill certain goals. What I try to do when I'm teaching students is I tell them how to use, let's say, one advanced solver using Python, but I also tell them how to do the same thing Excel with Excel solver, because I want them to have a simple tool that they can use for small scale things where they could sell optimization for the first time inside their company. I do have a tutorial about like a modeling and like a simpler discrete optimization problems. We can send that in the follow-up email, which tries to like give that an idea of like what kinds of problems and why would model them.
Another question that I see in the chat was, what coding websites would you suggest to enhance our skills more? Actually, what I do, and I still do this, every time I see a post, a blog post, a LinkedIn post, whatever, a reference somewhere to some library that I think would be interesting in the optimization space, I just add it to a list. And then every once in a while, I go through that list and I pull up the docs for all these different optimization libraries. And they could be solvers, they could be modeling tools, they could be extensions, they could be packages that help you tie machine learning and optimization together, whatever. And I give them a 15-minute usability test. And if I like it within 15 minutes, then I make it part of my stack. And if I don't, it's gone. And so what that makes me do is solve essentially the same problems with lots of different tools. And then you get sort of a sense of like, how do all these things operate? And I feel like it gets you sort of a deeper understanding of just like, how does optimization software work? And that's kind of what you want to know. You want to have an inherent feel for how optimization software and modeling works at the software level.
Now we've got Ryan's list of things as well that we can share out afterwards. So we've only got a minute left here, and there's a lot of questions that have still come in. So again, if you've asked a question and we don't have time to get to it today, we'll make sure to follow up by email. Ryan, Thiago, I'd like to try and close out today's session by putting you on the spot of what would be, of all the things that you've covered, So far during this discussion, what would be the 1 to 2 pieces of advice that you would give to all the people here today about practicing OR and decision science in industry successfully?
So, I looked at the chat. I was just looking at Q&A earlier. I would say that building fundamentals is very important. When we talk about AI, it's always very trendy. We're always talking about the latest architecture. If you do understand very well how a neural network works and then progress slowly towards other types of models, building those fundamentals, you can face changes a lot more easily. And with optimization, it's the same thing. Rather than thinking about like the latest development, if you start from the basics and you really understand your discrete, deterministic, linear optimization, and slowly move towards the more advanced topics, all these buzzwords, you're going to be able to fit them into what you understand. I would say like go from like building the fundamentals. If you're still in college, try to take courses, try to find interesting books, and learn as much as you can about the fundamentals. That's very important.
Yeah, I think for me, one would be get as much experience like working on technology teams as you can. And this is also sort of like this is the thing that will future proof you in your career against AI too, right? Um, the things that we don't necessarily learn in school are like, how do I work on a team? How do I give a status update? How do I align what I'm trying to do with the other people on the teams and the goals of organization? How do I understand the mission, vision, strategy of that organization and internalize it and then propose something new? How do I use revision control software and review a PR and break up work into manageable chunks? All that kind of stuff, but applied to your field, is really what will make you most successful in actually like creating value within an organization. And that's not something that we're going to be able to shift over to large language models or really any AI, I don't think.
All right. Ryan, Thiago, thank you. I'm going to share a couple of items that we can also share out via email today as well, just as future opportunities for learning. Also, some places where Ryan and Thiago hang out, actually, if you ever want to connect with them in other forums. There's a couple of items that are ahead on the calendar for folks that are interested. Optimization for All is hosting a session on open source solvers, which I know Ryan and Thiago touched on, as far as great places to get started or communities to engage with and participate in. Informs is also hosts monthly virtual happy hours. The next one is this week. And once you sign up for one, you get reminders for the ones that follow. For those that are going to Informs Annual, which is a large conference happening in Atlanta, Georgia this year, that's happening next week. Another conference to consider, I know we had quite a few people hailing from San Francisco today. ODSC AI West is happening next week as well. And then for folks that are in Europe, but they also have recordings and they share them afterwards, the Euro Practitioners Forum hosts a webinar series that is worthwhile. And the next one is with a great speaker on planning and scheduling logistics happening on November 7th. So, Ryan, Thiago, thank you very much for today's conversation. Really appreciate it. Again, we'll get to the questions that we weren't able to answer live today over email. Again, thank you everybody for joining. And Ryan, Thiago, thank you for the great conversation today.
Thank you.